to you about the real world development cycle of software and how it differs heavily from what you're taught in school. So, I don't want you to discount what you learn in school because it's extremely valuable and it's about 95% of the core work you're going to do on your job. But often, 80 to 90% of the errors or important considerations you want to have when you go into the real world from school are outside of that scope. So what you learn in your schooling is really development and how to do a unit test, how to do an integration test, and you learn this deeply. Whether you're doing computer science or some other form of software development, you're going to learn these skills pretty effectively in school. However, oftentimes the unit test is testing your feature, right? And the unit test is more than just ascertaining that that test is effective and that the code you're writing is effective and adheres to the unit test. It really comes out of the requirement you're getting, and those requirements are often gathered in abstract terms. Whether you're building a small utility to increase efficiency within a organization, you don't have to be a software developer to have an important understanding of the importance of the cycle, because anytime you're building software with business value or customer value, you're going to interact with the cycle in some form or another. Now, the way we describe it here is very academic, but really a requirement is just you're talking to someone and trying to understand what do they need. And this is obviously an important part if you're going to make use of software. And once they tell you what you need, you go and develop that. Whether that's an Excel sheet or a large-scale software program, it doesn't matter. And once you've finished that development and you go on to the testing stage, when you're doing unit tests, that's often a good time to actually go back to the person giving you the requirements or go back to your requirements and see if there's a gap between what was given to you and what you developed by the basis of what your unit tests are doing. And that can sort of build the cycle of you going back to development and adhering to those requirements by fixing something so that it adheres to a unit test that you now have changed to adhere more towards your requirements. This is a step that a lot of people miss, and it creates a large portion of the problems that might occur when you develop a software system. It's not necessarily that the system itself is not perfect or that the unit tests don't pass, it's that there's a gap between what the requirements were and what you actually built. And at the end of the day, you're building your software for a customer or client or someone to do some purpose. And if you're missing the purpose, that's not the right approach. And we often miss this, oftentimes because you don't really learn this or intuitively think about its importance. Another important consideration is around integration tests. Now, a lot of times we think integration or tests are just to test boundaries, but they're really to understand what are other teams doing. In complex software development, this is more important, but essentially, if you're integrating with a separate team that's doing something, you might not fully understand the contracts you're consuming or the things you're consuming and using them effectively. And so, integration tests allow you to get this sort of feedback because not every team, and especially when you have technical debt or if a software development team is developing and a company is developing rapidly, you want to use these integration tests to get a sync of what sort of communication you might be lacking. And that might involve, messaging the person and understanding, hey, this integration test's failing. It might be failing because you're consuming the contract because you're interpreting the contract incorrectly, or there may not be as much documentation in a contract. In an ideal software development situation, these things would be perfect, but that's not always the case. Oftentimes, when you're developing software, you don't have the ideal case, and that's when you really need strong communication skills. And after all of that, you also have to recognize that in software development, where you have a rapid pace of development of new features, this cycle going from development into testing and into deployment is very short. That means that you don't have a lot of time to catch issues with your code. That means you need to unit test well and integrate well, but you also need to communicate, because communication is the bedrock on which your software development is built. The unit tests and integration tests are more like slides in a PowerPoint. It's how you present those slides in the organization that matters. It's how you communicate back to the stakeholders that are viewing those concepts and tightly couple them to the deployment so that there's not a drift between what you're developing and what you need to develop, or the way you're developing it by consuming contracts and the way you should be understanding contracts. So these are some of the biggest gotchas in software development. At the end of the day, communication is key. You want to not just write these unit tests to pass, you want them to be a mechanism for communication. And at the end of the day, everything communicates back to requirements and an understanding of how you're consuming things in the software. Because Oftentimes, the thing that is most in your control is this box, and yet we often use these tests to consider what we have control over, when in fact we should be leveraging what we don't have control over and ensuring that we de risk those areas.